Welcome to today's explainer. Think of your upcoming computer science exam like a high-stakes space mission. Up there is absolutely zero margin for error. Every single calculation, every single procedure must be perfectly executed for a successful launch. Today, we are setting our sights on a notoriously complex area of the Cambridge AS and A-level computer science syllabus, specifically 9618. Though the exam strategies we uncover today will absolutely transform your grades whether you're sitting 0417, 0478, 0983, 0984, or 2210. We are going to completely demystify exactly how to master the tricky topic of microwaves and satellites in communication. If you want to stop guessing what the examiners want and start delivering it with precision, you are in exactly the right place.
Right out of the gate, we need to talk about this massive hurdle. The Principal Examiner report reveals a glaring issue, stating, examiners report that microwaves and satellites in communication is one of the most misunderstood areas in computer science. That is a huge statement. It tells us exactly why we need to master this material right now. To really understand why this is such a bloodbath for candidates, let me introduce you to two typical students we see all the time. Let's call them Alex and Sam. Alex is the kind of student who overloads every single answer with raw computer science facts. Alex memorizes the textbook, knows all the data, but provides absolutely zero analysis. On the other hand, we have Sam. Sam rushes through the paper, completely misses the specific command word requirements, and ends up answering a question the examiner didn't even ask. Both Alex and Sam walk out of the exam hall feeling great, but when results day comes, their papers are covered in red ink. Today, we're going to make sure you don't make their mistakes.
Okay, let's dive into this. Here is our roadmap for decoding the examiner's playbook. First, the exam challenge. Second, core principles. Third, technical methodology. And fourth, critical examiner warnings.
Section 1. The exam challenge, navigating unfamiliar contexts.
So why do students find applying concepts to unfamiliar contexts so incredibly hard? You might know the textbook definitions of how a microwave signal travels or how a satellite orbits. But the moment the exam paper places those concepts into a real-world scenario, like setting up a specific line-of-sight network in a harsh mountainous region, total panic sets in. Remember Alex? Faced with this mountain scenario, Alex will just brain dump 5 paragraphs about how microwaves work in a vacuum. Raw facts, no application. Sam will see the word satellite and rush into a generic explanation without looking at the command word, completely ignoring the fact that the prompt specifically asked to compare low Earth orbit and geostationary systems for this exact mountain terrain. This highlights the critical gap between rote memorization and true mastery. The examiner doesn't just want to know if you can read a textbook, they want to know if you can actually engineer a solution.
This brings us to the core issue: superficial breadth versus analytical depth. Top-performing students exhibit a connected, deep understanding. If you just memorize that microwaves are used for communication without understanding exactly why they require line of sight or how environmental attenuation physically affects the signal, you are stuck with superficial breadth. Cambridge academic benchmarks heavily prioritize logical reasoning and analytical depth over just having a scattered, wide-ranging knowledge of basic facts. To fix this, you need to use a framework. Top students structure their computer science answers using the PEAL framework. That stands for point, evidence, explanation, and link. You make your point, you back it up with technical evidence from the syllabus, you give an explanation of how it works, and crucially, you link it back to the specific, unfamiliar context in the question. Alex and Sam fail because they never reach that link stage.
Look at how the syllabus is actually graded across these 3 distinct assessment objective domains. It targets knowledge and understanding, application, and analysis. Notice that knowledge is just the very first baby step. You then have to apply it using that PEAL framework and finally analyze the outcome. Simply memorizing facts won't secure those top marks because you'll completely miss the points allocated for application and analysis. It's like building a rocket but forgetting to program the navigation system. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on to Section 2, Core Principles, the Method Mark Strategy.
Now, what's really interesting here is the method mark strategy. This is a fascinating marking principle where points are actually awarded for demonstrating the correct systematic process and clear working, even if your final result is flawed. This is literally the examiner's secret weapon, and it's the ultimate safety net for your grade. The problem-solving process is just as valuable as the final answer. You absolutely must show your work, your logical steps, and your algorithmic thinking. If you just do the mental math and jump straight to the conclusion, you leave so many easy marks on the table. Think back to our space mission. If the final trajectory calculation is slightly off, but the engineers documented every single formula and logic gate flawlessly, they still prove they understand orbital mechanics. That's what the examiner is looking for. Method marks are how you squeeze every single point out of a difficult paper.
We have a major examiner alert here. This is where we see the red pen marks start to transform into green check marks. Principal examiner reports reveal candidates consistently confuse key terminology when discussing microwaves and satellites. Alex might write, "The signal gets weak," while Sam writes, "The signal breaks." The examiner reads that and immediately deducts marks. The diagnostic fix? Always define your terms, like attenuation, latency, or specific frequency bands, before using them in extended responses. It proves to the examiner you actually know the vocabulary of the subject. When you replace "the signal gets weak" with "environmental attenuation degrades the signal," your mark potential instantly shoots up. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 3. Technical Methodology. The Deconstruct, Solve, Evaluate Framework.
Okay, this is where we turn our theory into an interactive workshop. Here is the 5-step computer science success blueprint sequence you need to internalize. First, deconstruct the question to identify exactly what command word is being used. Second, extract the relevant data given in the scenario. Third, select the appropriate analytical framework, like Peel. Fourth, execute your analysis with clear, logical notation. And finally, verify and present your results using the correct terminology. Let's do Challenge 1, the data scan. Imagine a complex data table showing signal degradation over distance in heavy rain. You've got 60 seconds on the clock in an exam. Your job isn't to read every number, it's to extract the core trend. The trend is attenuation increasing with precipitation. Following this exact 5-step structure guarantees you pick up those process marks we just talked about. It forces you to be systematic, taking you from 0% mark potential straight to 100%. When questions push into higher-order assessment objectives, like evaluating a specific algorithm used in a satellite communication protocol, you must evaluate it strictly against these criteria: time complexity, space complexity, edge cases, and their overall effect on performance. Let's do Challenge 2, Find the Flaw. I want you to imagine Sam wrote this paragraph. The satellite algorithm works well because it uses little memory, but it might take a long time to sort the data. Do you spot the flaw? Sam is losing marks here because there is no technical analysis. Sam identified space complexity by mentioning memory, but completely failed to use specific big O notation or explain the actual time complexity impact on the satellite's real-time communication performance. Justifying your recommendations based on these strict criteria is an absolute requirement for securing top marks in analytical questions. Under intense exam pressure, remembering all those criteria can be incredibly tough. So here's a quick memory hack directly recommended for this syllabus. Create your own mnemonic, using the first letters of those key terms: time, space, edge, effect. Let's jump into Challenge 3, Speed Writing. In the exam, you have roughly 30 seconds to plan out a perfect Peel paragraph in your head before writing. Using a mnemonic locks in these procedures so that when the clock is ticking down, your brain automatically retrieves the exact framework the examiner is looking for, without freezing up. It's about training your muscle memory so you can execute the operation flawlessly under pressure.
Section 4. Critical Examiner Warnings, Mistakes to Avoid.
Let's move to and see how this all builds up. Here are the top 3 ways students absolutely throw away marks, straight from the people grading your papers. Warning 1. Forgetting overflow and edge cases. The diagnostic fix is to always check your boundary conditions. Warning 2. Ignoring those boundary conditions entirely. We want to systematically test extremes in our logic. If we're simulating a satellite's trajectory, what happens at the exact boundary of its transmission range? If you don't test that edge case, your code and your exam answer fails. And warning 3, which is massive for microwaves and satellites, answers lacking specific context. If the question is about a low Earth orbit weather satellite tracking a hurricane, do not give a generic answer about geostationary GPS satellites. Tie every single piece of reasoning back to the prompt.
To bring this all together into the final system, you need 3 rules that guarantee top marks. Rule 1, command word decoding. Understand exactly what the examiner is asking. Rule 2, Peel framework application. Structure your knowledge so it actually translates into marks. Rule 3, time management matrix. Don't rush like Sam, and don't overwrite like Alex. Master the step-by-step framework, practice applying it to past paper questions, and always ensure your conceptual understanding is locked into the specific context you are given. This is how you shift from superficial memorization to the true analytical depth Cambridge demands.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCES and click that bell. Don't let another exam pass you by. So, I'll leave you with this provocative question. Will your next past paper answer successfully secure every single method mark? Now that you have the examiner's playbook, it's time to test yourself. Apply these steps to your very next study session. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.